Hi dear students, today we will discuss about the last part of your motion chapter, that is class 9 motion chapter, that is equations of motion. You see, I have already written 6 equations in two sides by making a demarcation line. What is this 3 equation? What we are going to do with that 3 equation, that we will see now. See, the first equation is written in the part of accelerated motion, that is v equals to u plus at. What is v? I am just mentioning the thing. V equals to final velocity, u equals to initial velocity, s equals to displacement of a body. So as we are talking about that, we are dealing here motion in one dimension, so here displacement or distance both are same, because as we are talking about straight line motion, so you all know for straight line motion distance and displacement is same. T time and a, occasionally it is acceleration or retardation. Now coming to the equations first. The first equation tells us v equals to u plus at, means here we are finding the final velocity, where initial velocity, acceleration and time must be given to us. S equals to ut plus half at square. Here we are finding the total displacement or total distance, where u is the initial velocity, t is the time, a is the acceleration, and third one is v square equals to u square plus 2as. V square means final velocity square, that should be equal to square of the initial velocity plus 2 into acceleration into total displacement. You are thinking from where the equations are coming. Yes, in this part we have to learn this, from where the equation has come. But before going there, you just come to the retardation motion part. Retarded motions, here when we are talking about, we have written the same equation using, instead of writing plus, we have written minus. Why you have written minus here? So to understand why we have written minus, we will go for the retardation. Retardation is what? Retardation is also rate of change of velocity when the velocity is decreased, or in another word we can say it is known as negative acceleration. So as it is negative acceleration, so here instead of a we have to take minus a. So in the equation, what is the accelerated equation? Here only you have write that v equals to u plus minus of a into t, and then the equation will come u minus at. Similarly, for the case of 2, here also instead of a we have taken minus a, that's why minus sign has come. For 3 also, for same reason minus sign has come. So minus sign signifies that instead of acceleration positive, we have taken negative acceleration. And the reason is that whenever we have done any numerical taking retarded motion, for there we have to remember that here instead of plus we have taken minus, so the value of retardation it is coming, that will not come with negative sign, that will come with a positive value, so that the value should looking good. Okay, so that's why this thing is occurred. So for accelerated motion we have to use this equation, for retarded motion we have to use that equation. Now proof of these 3 equations, let's see how we can able to prove it. Okay, I'm erasing this thing now. If you want to write it, pause the video here, write it down and go for the next. So when we are talking about proof, v equals to u plus at, very easy thing. we have already done that acceleration a equals to rate of change of velocity v minus u by t in the first part. So from here v minus u equals to at and v equals to u plus at. That is the general process to prove that equation. But if I want to prove it graphically, then we have to work little more. So graphical proof means here in this three equations proving case, I have to draw velocity time graph. Assume here velocity, here I am taking time. Okay, so it is y-axis, it is x-axis. No need to tell why we have taken t along x. Everything we have learned, we have done it earlier. And assume the graph seems to be looking like this. Okay, so this point we know it is the origin. That means here time t equals to 0. So it is the initial velocity u. Okay, and that length represents u. And when it reaches to this point, assume this point is b and here this point is a. Okay, in b point we have to draw a perpendicular to the t-axis. Assume this time is taken as t. So here we have written t because we want to show it's a time axis, and the next place we have written t, that is the time t. After time t means at b point the time is t. Now coming to the another way, if I draw a perpendicular here, at this point the velocity will be v. So here v, it is stands for the velocity axis. The next v stands for the velocity at b point. What is the velocity? So this length, this total length represent velocity v. Okay, so I have taken here a, taken here b, and right here c. This point we have taken, it is c. Just follow the steps. Now we know that for a velocity time axis, if I find the slope, that slope will gives us the acceleration. So we know that slope of velocity versus time graph gives us acceleration. Now the question has come, how can we able to find the slope? So slope means what? Slope means the angle is made by the graph with x-axis. Angle is made by the graph with x-axis. So what can I do? We have to draw a parallel line from of x-axis here. Assume it is touching in this point at D. So this angle, this is the angle, if I tell it is theta, that should be the angle which is made by x-axis also, because this line is parallel to it. And if you say, no sir, how do you understand? Just extend this and extend the x-axis. You see, this angle and this angle, it is same. Okay, these two angles are same. So this is slope, and slope means, so slope theta equals to perpendicular by base. We have learned theta means it is tan theta, and tan theta equals to perpendicular by base. So BD by AD. Instead of BD, can we able to write it BC minus DC? BC minus DC. This total minus this one, that will also give BD by AD. Instead of AD we can write OC, because AD and OC are same and parallel to each other, so we can take it. Now here you see BC, this total length, okay, that will be equal to this length that we have taken V. So BC length is nothing but V. If I am talking about this DC or CD, that is equal to this length. Okay, so that should be equals to U, and OC is T, I have already taken. So it is t. And we know slope theta equals to acceleration a. And from here we can write v equals to u plus at. Okay, so graphically we shown from where the v equals to u plus at has come. Okay, pause the video, write it down, and then we will go for the next. Okay, we are going for the next equation. I think it is clear enough. What we have done? Nothing. We have taken the triangle, so we can mention here that from triangle ABD. From triangle ABD, we have taken BD by AD, and BD, that means BC minus DC by OC, and then we have put the value. Okay, so it is graphically proved. Then we will go for the next equation. Let's see. If you are not able to write it down, pause the video here and write it, and then we will go for the next. Our next equation is S equals to ut plus half a t square. S equals to ut plus half a t square. So it is an equation where we are finding the total displacement of our body. Okay, assume, if I want to prove it generally, then assume a body is moving with velocity u after t time. Velocity is equals to v. So that is the simple thing. Initial velocity is u, final velocity is v after the time t. Now if I want to find the average velocity here, average velocity, we have done earlier also. What should be the average velocity? You see, we are having two velocities, v and u. So we can do v plus u by 2. If it is told to you to find the average weight of your class, how can you able to do? You have to add all the students' weight in your class and you have to divide by the number of students. That same things I have done. There are two velocities are given. Adding these two, dividing by 2. Okay, so we'll get v plus u by 2. Then distance is equals to v average into time, because the velocity is not constant, velocity is changed continuously from u to v. So if I want to find the distance, we cannot able to multiply time with any of the velocity. Instead, I have to find the average one and then multiply it. So average velocity is what? V plus u by t. So S equals to v plus u by 2 into t. Again, we know that. What we know? We know v is equals to u plus at. That we know. V is equals to u plus at. Put the value here. So S equals to u plus at plus u into t by 2. So u plus u, 2u plus at by 2, okay, into t. So I think it will take much place. Okay, if I multiply here, so it is coming 2u into t by 2, because t is in outside, I multiply, plus at square by 2. So 2 will be cancelled out. So S equals to ut plus half a t square. See, it is the general method to prove of S equals to ut plus half a t square. It is the general method for proving is equals to ut plus half at square. Okay, if you want to write it down, pause the video here and see how the proof is done. Nothing, I am taking just the average velocity and multiply the time to find the distance. So average velocity into distance, average velocity into time, we find the distance. Now if I want to prove it graphically, we have to draw the same graph that we have drawn earlier. Time, velocity, it is y-axis, it is x-axis, okay, and this is O, that is the origin. So assume it is a velocity time graph, and whenever we have to start drawing, we have to think that the body should be an initial velocity. Okay, so this is the point from where the velocity is starting, the graph is starting. So that point gives us the initial velocity u. This point is being denoted by a. Here the point is denoted by b. I have to draw a perpendicular here. So in this point the time is taken t. I have told earlier also, this t is for axis, this t is the value that at b time, at b point the time is t. Okay, so that's why I have given different color. And here if I draw a perpendicular to the velocity axis, here the velocity is v. So it is a, b, and this point is c. Okay, now what we have to do? Now we have to find the total distance, because you see the result. In the result there is acceleration, there is total distance s, and we are not thinking about the slope here. So we know that area of velocity time graph with time axis gives us total displacement. So if I want to find the total displacement, then that should be the area, okay, of the velocity time graph. Now how we can able to find the area? So for that I have to use a very easy technique. I have to draw a perpendicular from A point and it will touches here at D point. Okay, and here it is O, it is A. Okay, now if I able to find the area of the rectangle and area of the triangle, then it is very easier for us to find the total area. We have to find the area of rectangle and area of triangle, and then we will add it, because this area we have to find out. Area of velocity time graph with x-axis or time axis. So that total area we have to find out. So to finding the total area, what we are doing? We are just separating rectangle and triangle and then we add it. Okay, so total area is equals to area of rectangle plus area of triangle. Equation of area of rectangle. So equation of area of rectangle is length into breadth. So length is what? Length is AD, breadth is DC, okay, or AO, whatever you can take, plus the area of a triangle, half of base into height. So here this is the base AD and height is this one BD. So this is the height and this is the base, half of AD into BD. Let's see. So instead of AD into DC, I can write it. It is also, you can keep it like this way, but you can write OC into OA plus half of AD. Instead of AD, we can write OC because these two lengths are same. OC into BD. So BD means, it is clear, it is BC minus CD. BC minus CD. We can write it. Just see it. Okay, half of OC and BC minus CD. Okay, let's see. OC into OA. OC into OA means OC is what? It is T. OA is what? It is U. That means T into U plus half of OC means T. BC minus CD. BC minus CD means BC equals to UC. It is the total length. So total length, this one should be equals to this, and that length is V, the final velocity, V minus U. Okay, now we have to again take a help of the previous equation. In previous equation we have learned that A equals to V minus U by T. That is the equation of acceleration. From here we can write V minus U equals to AT. So we have to put the value of V minus U here. So if I put it, it will come UT plus half into T into AT, or UT plus half AT square, that is your S. Because we know total area covered by a velocity time graph should equal to its total distance. Then you see our answer has come, that is S equals to UT plus half AT square. I think it is clear enough for you to understand. If you want to copy it, pause the video here, copy it, try to understand, and then go for the next. Now step by step we have come to the last portion. Okay, I'm just erasing this one, the middle portion. Rest of the thing I'll not erase, because if I erase it, it is difficult for us to do. And here also I'm erasing only this, the lower portion. Rest of the thing I want that it should be there exactly the previous. Here also I'm just erasing this one. Rest of the thing will be same, because I just don't want to write two times the same thing. So this thing, what is there earlier, the same thing is there kept. We have to do the last equation, that is V square is equals to U square plus 2AS. Here also I am taking the same thing, that a body is moving with a velocity U. After t time the velocity is V. We have taken average velocity, that is V plus U by 2. Total distance, because here you see S is there, and whenever we will see there is a S, we will not go further. We will just use the same technique, that is finding the average velocity and multiplying with the time to get the total distance that we have done. That is S equals to V plus U by 2 into T. Now this T, previously whatever we have done, we have not changed T, we have just taken the value of V, that is U plus AT. Here we will change the value of T. How? We know that if I have written here that V minus U by T equals to A, right, the previous equation, and V minus U by A equals to T. We know that. Just I am interchanging the position of A and T, nothing else. Rest the thing is same. So here instead of T I have to put this value, that is V plus U by 2 into, instead of T, V minus U by A. Okay, that is equals to S. Now S equals to V plus U into V minus U, A plus B into A minus B, that is A square minus B square by 2A, or V square minus U square equals to 2A into S. By cross multiplication and v square equals to u square plus 2as. This is our equation. So our equation is proved in general method. Our equation is proved in general method. What we have done in the previous case, only we have to follow the same technique, but I have changed the equation because you see in this equation there is no t. So as there is no t, so instead of t I have taken this value. So the first equation will come several times in different pattern. Now I am coming to the graphical representation. Here you see in graphical representation, here also we have to find the area, because as we have seen the displacement is there, S. Whenever we have seen this S, we will forget everything. We will just remember I have to find the area. Now you can say, sir, in the previous part also we have find the area and we have got a different equation. Here also we have to find the area, but in different order. In the previous part, I have divided it into rectangle and triangle. But here, I just want to find the area all together. Okay, all together we have to find this area. What will be the shape looking like? The shape will be looking like this little bit. Okay, what type of shape it is? It is nothing but a trapezium. So it is a trapezium. So we have to find the area of trapezium and we know the equation. So we can say total area should be equal to area of trapezium. So area of trapezium equals to what? Half into sum of two parallel sides into height. That is the equation. Half into sum of two parallel sides into height. So here you see half parallel sides, this one and this one. So we can say it is BC plus AO. This is parallel to this one, just like this. Okay, so BC plus AO, two parallel sides into height. Height means this height, that is OC. So half into BC plus AO into OC. Okay, put the values. Half BC means I have just done it from earlier, that it is V. It is the final velocity. The total length will represent the final velocity V. So V plus AO, it is equals to U. OC, that is equals to T. Again there is a problem. It's nothing a problem. We have just done it earlier that V minus U by A equals to T and T equals to V, I'm sorry, I have already written it. V minus U by A equals to T. So instead of T, I have to write down here half of V plus U into V minus U by A. So exactly same calculation like this. So it will come. So here total area is total displacement S, that is equals to V square plus U square. I'm sorry, V square minus U square by 2A, or 2A is coming here. So V square minus U square equals to 2AS, and that is V square is equal to U square plus 2AS. This is the equation what we have proved graphically. See, one thing we have to remember here, that when we have to find the area of trapezium, we'll get this equation, and if I want to find the area separately by rectangle and triangle, then I'll get the previous equation, and if you remember it, it will be easier for you to do the numerical. Okay, I think it is clear enough. Now I'll just practice some numerical. So first numerical we'll discuss here. Mainly we have to do the last three numericals. I think it seems to be harder for you, so that one will do it, but rest of the numericals I'll suggest that you will do it by your own. So numericals, exercise 2C, I think, if I'm not wrong. Let's see, exercise 2C. Okay, and we'll start by the numerical 13, because we will do 13, 14 and 15, last three numericals, and then I think these are enough for you. 13, what it is told, and you see how we have to do a numerical, the procedure. It is told a car travels with a uniform velocity 25 meter per second. So uniform velocity means it is a constant velocity. So you have to write u equals to, because u is initial velocity as it is moving with constant, so it is u equals to 25 meter per second. It is given to us. So first we have to write what the things are given to us. So given u equals to 25 meter per second for 5 seconds. So t1 is equals to 5 seconds. Why I have taken t1? Because that can be changed also. Okay, many more time can be given. Then I have to take it t2. Next, the brakes is applied and the car is uniformly retarded and it comes to rest in further 10 seconds. See, further 10 seconds is there. So another time. So brake is applied. So as brake is applied, it is told the car is coming to the rest. Car is coming to the rest means v equals to 0, because as it is told rest, so final velocity will be 0. So initial velocity is 25 meter per second, final velocity is 0, and how much time taken to make the velocity 0? That is 10 seconds. Okay, these two informations are given to us. Now the question number 1. It is told find the distance which car travels before the brakes applied. So distance traveled, distance we generally denoted by s. So here first distance s1, constant velocity, that is u 25 meter per second. How much time it will go? 5 seconds. So s equals to u into t. Now you may ask, sir, why there is no other part? Because we know if the car is moving with a constant velocity, then why we have to take that acceleration? Because no acceleration is there. As we have to mention, as there is no acceleration. No acceleration is there. So that's why there is no other part, only s1 equals to u into t. So value of u equals to 25, time equals to 5. So it is 125 meter. Okay, first part is over. Coming to the second part. In the second part it is told the retardation. Okay, find the retardation. Okay, retardation means a. So see, v is given to you, u is given to you, okay, and time is given t. We all know for retardation v equals to u minus at. Now you may ask the question, sir, how you can able to understand that this equation we have to use? See, very simple thing. What informations are given to you, by that information only you have to find what information is unknown to us. It is asked that you have to find a retardation or acceleration, we have denoted by a. So we have to go by the given chart. U, it is given to us. V, it is given to us. Time, it is also given. No displacement or no distance, nothing is given. So we cannot go for the next equations we know. We will not go for that. We will just go for this equation because rest of the things are given. So from here we can write A equals to U minus V by T2, because the time taken we have T2, because after break the time is 10 seconds. So U is how much? 25. Okay, V is 0. T2 is 10. So it is 25 by 10. That means 2.5 meter per second square. That is your retardation. 2.5 meter per second square. Coming to the third point, third result. What is the question? The question is asked, the distance traveled by the car after applying brakes. After applying brakes, how much distance it covers? Because you see, after applying brake, it will take 10 seconds to cover the distance and then it stops. Whenever we will go by car or bike, suddenly whenever we have applied brake, it will not stop suddenly. Okay, and we don't apply the brake suddenly also. We will take some time. If we see some congestion is there, we apply the brake very loosely, so that after covering some distance, the car or the bike can stop. So here we have to find the distance the car covered after braking. Okay, so which equation we have to follow here? As we have to find the distance after braking. Let's, it is taken by S2. So if I have taken ut minus half at square, a it is given to us, we have calculated, t it is also given, and u is given. So we will go by that equation. Okay, if I go by that equation, it is possible. So S2 equals to ut minus half a t square. Okay, so let's see. S2 is equals to u into T2 minus half of a T2 square. What is the value of T2? It is u equals to 25 and T2 equals to 10. 25 into 10 minus half of a equals to 2.5 and T square means 10 square. Okay, so if I calculate here, it is 250. And here it is 10 square. 10 square means 100. 100, if you just cancel out here, it will come 50. So 2.5 into 50, so it is 125 coming. Okay, and if you cancel out, it is 125 meter. So after brake also, the car will move by 125 meter before stop. Okay, now you may ask, sir, can we do it by another equation, that is v square is equals to u square minus 2as? So this is also an equation. Sir, here no time is there, but rest of the thing also we know. Yes, we can do it. Here you see a is equals to u square minus v square by 2a. See, a is equals to u square minus v square by 2a. U square means 25 square, v square equals to 0, 2 into 2.5. Okay, so if I write it here, 25 into 25 by 2.5 into 2. So 2.5 tens are 25. Point is there, 2 fives are, and it is 125. Any equation we can able to use it. It is not like that which equation I have to use, you have to use that equation only. No. What informations are given to you, based on that you have to choose the equation. Okay, let's go for the next. If you want to copy it, pause the video and write it down. Okay, we'll go for next numerical, that is question number 14. Question number 14. Let's see, can we able to do or not? What it is told, let's see here. Question number 14, it is told a spacecraft is flying in a straight course with a velocity of 75 km per second. So given, what thing is given? It is moving with a speed of 75 km per second. So u is already given, 75 km per second. Okay, now you may ask, sir, can I convert it into meter per second? We can convert it, but see in which order the answer has asked. Based on that only we will change. Next, fires its rocket motors. Rocket motors means such kind of motors, so that the speed of the spacecraft will be increased. So fires its rocket motor for 6 seconds. So time t equals to given 6 seconds. At the end of this time, the speed is 120 km per second. So v, final velocity is 120 km per second. Rocket motor means it's a special kind of engine, so that if it fires at backward direction, then the spacecraft will move in forward direction. This type of videos are huge in YouTube. If you go through how a spacecraft move, how its speed is increased, you can able to understand. Whatever. First question is find the craft's average acceleration. So acceleration A is asked. Average acceleration means the acceleration. If I go by this way, because we know acceleration A equals to V minus U by T. Simple equation. So V, value of V, it is given 120 kilometer per second. So both the things are kilometer per second. So we will not change the unit. And you see the answer is coming is also kilometer per second square. So let it be kilometer per second square. 75 by 6. So 120 minus 70, it is coming 5. One thing will be taken. It is 45. Okay. So yes, 45. So 45 means 3 2s are 3 15s are, so it is 7.5 kilometer per second square. For meter per second square, it will be changed to kilometer per second square. That should be the acceleration of the spacecraft. Now we have to come into the next part. The distance traveled by the spacecraft in first 10 seconds after the rocket motor start. Okay, and the motors have been action for only 6 seconds. Very interesting part. See. Now understand the question, otherwise you cannot able to do it. It is told after the rocket motor start. So it is start for 6 seconds. It is already told. So from when it is start, after that t equals to 10 seconds, you have to find out that how much displacement is occur. In 10 seconds, it is actually divided by 6 seconds plus 4 seconds. In 6 seconds, velocity is increased by 75 kilometer per second to 120 kilometer per second. In first 6 seconds, it is increased by 75 kilometer per second to 120 kilometer per second. That we have seen already. And last 4 seconds, spacecraft moves by constant velocity. What should be it? It should be 120, because after getting 120, it is moving with 120 because no motor is started, because after 6 seconds it is stopped. So that means we will just think it will be 120 kilometer per second. Okay, I'm just explaining this again. The total time for displacement, it is taken 10 seconds, and in between the 10 seconds, 6 seconds the motor has been on. And when the motor has been on, the velocity is increased 75 to 120. And after that the motor off. And when the motor will off, we will think the velocity should be constant 120, and by 120 it will go further 4 seconds. So we have to find two distances for first 6 seconds and next 4 seconds, and then we have to add it. Okay, then we have to add it. I just want to see whether the things has been shown in camera or not. I have written little smaller, so if you pause it and see it, I think you can able to understand. Next, displacement in first 6 seconds. Okay, so displacement occurred in first 6 seconds. Now the question has come, sir, which equation we have to use here? I am telling you, you can use any equation, because you see you are having A, you are having T. So either you can go by S1 is equals to UT plus half a t square. Or you can say that, sir, a is there, so I can go by v square equals to u square by u square plus 2a, as b is also there. You can go by that way also. I don't have any problem. You can use any equation. I just want s. Okay, I am going by this equation. So s equals to ut equals to 75 into t equals to 6 plus half of 7.5, because acceleration we have find out 7.5 into t square, that is 36. So 2 18s are 36. 75 into 6 is 450. 6 5s are 30. 6 7s are 42 plus 30 450 plus 18 into 75. 18 5s are 90. 0. 9 is in our hand. 18 7s are 126, I think. 126 plus 9. So 135 and point is here. So it will come 5 8 5. Okay, so this much of meter, that is S1, first 6 seconds, and displacement in 4 seconds. So it is S2. So here you see no acceleration is occurred. In S2 there is no acceleration occurred. So it is simply V into T. V is 120 and T is how much? T you see 4 seconds. Okay. So just add it. Multiply. 480 meter. And now total S1, S equals to S1 plus S2. So that is 585 plus 480, and it 5 18 16 6 and no 1065 meter. 1065 meter, that is the total distance covered in 10 seconds. It is the total distance covered in 10 seconds. Okay, I think it is clear enough. Okay, if you want to copy it, pause the video here, copy the numerical, try to understand. And I am going to the last one. The weather is very hot, you can feel, because the condition you see due to the video I have told earlier also, I cannot able to on the fan, otherwise you cannot able to get my sound properly. There will be a sound of for the fan, and whenever I off the fan, so my condition you can able to feel what is going on. Coming to question number 15, and it is the last part. So 15, I'm not telling it is hard, but it is lengthy. Okay, very much steps are there. You see 4 questions are coming, so step by step we have to go forward. A train starts from rest. First information, u equals to 0. Starts from rest means the initial velocity is 0, so u equals to 0. Uniformly at a rate of 2 meter per second square for 10 seconds. So acceleration a equals to 2 meter per second square and time t equals to 10 seconds. Okay. It then maintains a constant speed for 200 seconds. So t1 we have to take, and here we have to write constant speed for t2 equals to 200 seconds. And then brakes are applied on the train, uniformly retarded, and come to rest in 50 seconds. Come to rest means final V2. Why I am taking V2? You will understand. So final velocity V2 equals to 0, because it is coming again rest, and here the time is taken t3 equals to 50 seconds. So 3 steps. if you want to show it graphically, then it is very easier to do. So the graph seems to be looking like this. It is a velocity time graph. Now you may ask that no graph is told to be done. Why you are doing graph? So I am doing the graph to make you understand the motion. So first velocity is increased. Okay. Then it is for 10 second. Time is 10 second. And then it will go constant for 200 second. Okay. And then it is retarded in 50 second. Okay. So it is 50 second and it is 200 second. Okay. So it is O, A, B, C. Three part is there. So from O, whenever we have to start, the initial velocity is 0. Then after that, after 10 second, it will get a final velocity here. So it is V1 I am taking. So what is the question? First question is asked, find the maximum velocity reached. So maximum velocity means what will be the velocity at point A when it will reach. So we know for accelerated motion v equals to u plus at. So v1 equals to value of u equals to 0 plus a equals to 2, t equals to 10. So it is 20 meter per second. That is your v1. So your v1 is coming 20 meter per second and it is the constant value. By that it is moving. Okay. So velocity equals to 20 meter per second. What is the next question? Number 2, retardation in the last 50 second. Retardation in the last 50 second. I am coming here. You see the velocity at A, that it is 20 meter per second. V1 is equals to 20 meter per second and by that velocity only coming here. So here when we are talking about u at B point, we can write here at B u equals to how much? Now u equals to here 20 meter per second, because after that it is decreasing. What is the final velocity at A? That is the initial velocity at B. Okay, no velocity changes occurred till then. So 20 meter per second. Final velocity it is 0, time is 50 second. So here acceleration, if I want to find out, it is retardation. So V equals to U minus AT for retarding motion. Okay, so A equals to U minus V by T. Value of u equals to 20, value of v equals to 0, time equals to 50. So 0, 0, 2 by 5. So 0.4 meter per second square. Okay, that is the retardation, that is 0.4 meter per second square. Okay. Next, total distance traveled. Okay, total distance traveled means in the whole path how much distance it travels. So we will find separately the distance travel in first part, distance travel in second part, distance travel in third part, and then we have to add it. Okay, so let's coming to distance traveled in first part. Okay, so assume this is the first part 1, this is 2 and this is 3. Okay, let's see how much distance is traveled. If it is a question of graphical representation, then we can able to find the area of the graph and then we'll get it. Okay, I'll show you that if I find the area of the graph, then also our answer will be same. Let's see. Distance traveled in first part, that is S1 is equals to ut plus half at square. So what is u here? 0 into t is 10 plus half into a is 2 into t square means 10 square, that is 100. So 2 will be cancelled out, it is coming 100 meter. So in first part it is gone by 100 meter. Coming to the second part, distance traveled in second part. So when we are talking about distance travel in second part, here you see the statement, the body moves constantly for 200 seconds. 200 seconds it is moved constantly. What is the velocity here? Now v equals to 20 meter per second. See, the velocity is 20 meter per second, and by that it is moving for 200 seconds. Time is 200 seconds. So distance s3 equals to v into t. As it is a constant velocity, so no acceleration is there, so that's why I have not making any a, so it is 200 into 20, that is 4000. Okay, 4000 meter. That is the total distance in second part. Third part, S3, that is also you can take ut plus minus half at square. Why I have taken minus? Because the last part, the third part, it is a retarding portion. Retarding portion means velocity is decreasing. So u is there 20 into 50. Okay, because time is 50, here it is given, minus half into 0.4 into 50 square. Okay, so do it 20 into 50, it is 1000. Okay, minus half into 0.4, so if I cut it here, it is 25. 25 fours are 100 into 50, 500 minus 0.1, 500. So it is 500 meter in third part. Okay, so if it is told you have to find the total distance, so for total distance I am coming here, total distance s equals to s1 plus s2 plus s3, that is 100 plus 4000 plus 500, that means 4600 meter. 4600 meter, that is the total distance covered by the train. Okay, we'll going for the next part. Let me erase something. What is the average velocity of the train? Average velocity of the train. I'm erasing this portion, then it will be easier for us. Average velocity. Average velocity, how we can able to find the average velocity? Now average velocity is total distance by total time. Average velocity is equals to total distance by total time. The total distance we have find out, it is 4600. Total time we have seen 10 into 200 into 50. 10 plus 200, I have told into, sorry, plus 50. Okay, so it is 260. 4600 by 260. Okay, so calculate it. 0 0 will be cancelled out. 13 230. Okay, 13 ones are 10. Okay, 100. 7s are 91. 9. Okay, it is now 91. Okay, 91 means 9. If I'm taking point 10. Okay, 13 7s are 13 8s are, no, it is not possible. 13 7s are 13 6s are we can take. Okay, 13 6 are 78, and then 9s are, oh, it will not complete it, it's approx this much meter per second. Okay, 17.69 meter per second. So we'll get an approx value, we'll not get a exact value. Okay, so this is the average velocity, that is total distance upon total time. Now I just want to show you one thing, that I have find the distance, so hard process finding each displacement and then add it and we'll get. If I find the area also, I can able to find the distance. If I find the area of this graph, okay, so it is a trapezium, you see. Okay, so trapezium means if I am putting the name A, B and OC, so area of trapezium, just now I have told that half of sum of two sides, that is AB plus OC into height. Height is this one, that anything we can take, assume it is D into AB. AB, what is the value of AB here? AB is 200, 200, and this one you see it is 200 plus 50 plus 10, that is OC 260 into AD. AD is the height, so what it will be? It will be the velocity, that is 20, it is 10, 460 into 10, that is 4600 meter. You see, if I find the area, then it is coming very faster that what is the total displacement by the body. Okay, so any step you can follow, but as here not told for doing the graph, I think you will go by the previous process. See the steps. Okay, we have drawn the graph. It is for making you understand that first it is increased up to 20 meter per second, then it is going constant, and then it is decreased. So 3 steps are there, so we have to find it in 3 different steps. Okay, I think it is clear enough. Thank you.